Hi, Chris Good here, and this is an introduction to R, and it's running in a program called RStudio, and we're going to use it to do the first statistic of the semester, the independent samples t-test. So if you've installed R and RStudio correctly, you should see something that looks kind of like this. It might look a little bit different if you're in a PC. I'm running a Mac right now. If you're running Windows or Linux, it might look a little tiny bit different. But you should see 4 different areas. And if you don't, you might want to click on this and start a new R script. That will open up this area, which is the script editing window. This area down here is called the console. This area allows you to see history, connections, and the global environment. And this allows you to view plots, packages, and files, and other things down here. Mostly we're going to be working here in the script editor. This is where you write code and edit it before you run it. Down here you'll see the results of running code that you write in the editor window, and up here you're going to be able to import things, look at the history of actions that you've done, and connect to databases online. We won't be doing that too much. This area down here, in addition to viewing graphs and other things, also allows you to install packages. These are helper files that you might need to install to get some increased functionality out of R through RStudio. We're not going to do that today, but we will in a later video. Okay, so we're going to learn to do the independent samples t-test in R, and in order to do it we need some data. I've prepared 2 Excel files, and I'm going to import them using this menu right here, Import Data Set. Now, if you don't see all of these different things here, you probably need to upgrade your version of RStudio to the latest one. And the first time you click on one of these, we're going to import from Excel. It might tell you that it needs to install some packages. Just allow the program to do that and wait till it's finished, and then you'll see this screen, the Import Excel Data browser, and I'm just going to browse to my desktop, find Ginkgo 1, and you should recognize these data as the lower variability data set. Now, I've expressed them a little differently here. What I've done is I've given 20 participants each a number, 1 through 20, and I've said what treatment they received. 10 of them received control, the other 10 received Ginkgo, and then I've put their memory score here in this third column over here. In order to get R to run the t-test the way that we're going to do it today, there are a couple of different ways to do it. You have to have your data formatted this way. You don't necessarily need a participant number, but I think it helps you understand that the first 10 participants, not the first 10 who arrive, but we have the first 10 numbered participants who are randomly assigned to get the control, and these numbered participants 11 through 20 randomly received Ginkgo. These are the memory scores from everybody. Just click on Import, and you'll see a new tab opened here in the script editor area. This is not a script, but this is actually the data file that we're going to be working with, and it shows you 3 variables at the top: participant, treatment, and score, and we'll be working with those names here in the script editor. Now, you'll notice that I've written a couple of things in the script editor already. This is just a title, and notice that I've used this hashtag symbol. Anything that follows a hashtag is going to be ignored by R. That means when you run this line, right, if we clicked on this run button, nothing would happen. Right? It says unexpected symbol. This will pull. It really actually is ignored. So if you just run that line, run this line, run this line, nothing, it just repeats what you just said to it. Okay. So we've already imported our data set, and now it's time to run the t-test. It's very simple. You just type this command, t.test, and then open parenthesis, and then you want to type the dependent variable name. Now I'm going to go back to Ginkgo. The dependent variable name is score, so I'm going to type score, and then I'm going to hit the squiggly line. It's called the tilde. On mine it's the shift and then the key next to the 1 button. It may be in a different place on a PC, but that's the tilde. It's not a dash, it's a little squiggly dash. Then I'm going to type the name of the independent variable. This is treatment. So it varies in 2 ways. You are either in control or the Ginkgo group. Treatment is the independent variable, score is the dependent variable, it's what was measured, and the t-test command needs the dependent variable first and then the independent variable treatment next. Next, you need to say that this is coming from the Ginkgo 1 data, and the last thing I'm going to type is something that says var.equal equals TRUE, and it's capital TRUE. Now, one thing about writing code is that if you make even the slightest spelling error or put a space in the wrong place, it's not going to work. So make sure yours looks exactly like this. You don't actually need this space here or the spaces after the commas, but I'm just going to leave it alone for right now. Okay. So that's the code, and now we need to run it. You can press the run button and it'll run that line, or you can hold down the command button and hit return, or on a PC you hold down control and hit return and it'll run line 4. And down in the console we see the output, the result of running line 4, and it says 2 sample t-test. It shows you the data. It used score by treatment, the dependent variable by the independent variable. It gives you a value for t, and you'll notice that it's negative, and that's because mean 1 was the control mean 2 was the Ginkgo mean, and it subtracts mean 2 from mean 1, and that's how t ends up being negative. Gives you degrees of freedom, and it gives you a p-value, only this has a little e in it. It's expressed in scientific notation. So 2.94 e negative 13 means it's 2.94 times 10 to the negative 13th. That means there's 12 zeros as a decimal, 12 zeros, and then 294. So the p here is really, really small. It's certainly smaller than a reasonable alpha like 0.05 or 0.01. Some other information it gives you is a statement of the alternative hypothesis, which I don't think is really that important. It also gives you something called a 95% confidence interval. And what that suggests is that we're 95% sure that the true value of the difference between these two means, which in our samples was, what, 9.7? In the population, that difference, we're 95% confident that it lies somewhere between negative 10.78 and negative 8.61. So there's, in the population, a negative difference between these two, which agrees with this t-test and p-value that we'd reject the assumption that the difference in the population is 0. It's not. It's directional, and it means that this one's smaller than this one. That really is as simple as it gets. I would like you to write a little summary of what this means, and you can use the hashtag before your APA-style sentence. So what would we say? Participants taking Ginkgo scored significantly higher than those taking a placebo. And then we'd give our t results. So t is equal to negative, t and then degrees of freedom if 18 go in the parentheses. It's equal to negative 18.75. We'll round to 2 decimals. P is less than 0.05. It's a lot smaller than 0.05. I don't want to type in all those decimals, so I'll just say it's less than alpha. Okay, well, let's import that other data set where we had much more variability but the same means. So I've got that in a file called Ginkgo2. Import. Gives you preview. Go back to the script editor. Now we'll do the same thing. T-test score by treatment. Not a dash, it's a little tilde. Data this time equals Ginkgo2. Did you see that? So it actually is doing some predictive typing there for you. You can just highlight that and hit tab or return, or highlight that and hit tab, or just click on it and it'll fill it in for you. I'm going to say var equal. This just means that the variances are equivalent enough to do a regular old t-test, and they're fine for that. Okay. So now you can hit run, or just hit Oops. What did we call it in Ginkgo 2? Oh, I didn't update this name. I called it control. That's bad. Let me fix that in the Excel spreadsheet. And then I'm going to re-import this data set again. Don't worry, your data sets are all set up for the homework to be just fine. There we go. Import that. Just run that line one more time. All right. Oh, it's in all caps. Like I said, in coding, you have to type it exactly as it's written, or it won't work. Okay, so now when we do score by treatment, t is not negative 18, it's negative 1.8878, same degrees of freedom because it's the same number of scores, and this time the p-value isn't quite as small, it's 0.07528. That's larger than a reasonable alpha, so we're going to retain the null hypothesis and conclude something different here. This time, the degrees of freedom stay the same, but the t-value is different. It's 1 point, I'm going to round to 89, and I'm going to say that p is equal to 0.075. All right. So you're going to be downloading the Excel spreadsheets for t-test practice 1 and t-test practice 3. Those are the data from problems 1 and 3 from the back of the Good and Sheehan textbook, and they will be set up just like these spreadsheets have, and just do pay attention to the names of the variables, especially these. It should say the same thing, treatment and score, but they might have slightly different names. So you're going to write a script that's slightly differently from that, and also make sure you use the hashtag before you write your sentence, and save that script file and upload it to the Dropbox on iCollege. And if you get into any trouble at all, please send me an email and I can help walk you through using R. Thanks. We'll see you in the next one.